Welcome to this Cycon machine learning tool tutorial. In this session, we'll be demonstrating how to perform a multi-class, multivariable classification using the decision tree classifier. Our object is to predict a patient's diabetes condition based on various health-related features. We'll walk through the dataset, explore the input features, build the decision tree model, and finally evaluate its predictive performance. This slide introduces the dataset used for this classification task. The dataset contains 265 rows and 12 columns, representing different patients and their associated medical conditions. These features include values such as blood markers and health metrics. This structured data will help us classify patients into different diabetes-related categories using a machine learning approach. Here, we define the input and the target for our classification model. The input features include various medical indicators like urea, creatine, HbA1c, cholesterol level, HDL, LDL, BMI, and more. These are used to predict the target class, which represents the diabetes condition. The target is a categorical variable with three classes: non-diabetic, diabetic, and predict diabetic. This richness of the features allows the model to learn complex patterns for accurate predictions. This slide focuses on the decision tree classifier, the model we will be using for this task. A decision tree works by splitting the data based on feature thresholds that reduce impurity, using criteria like Gini index or entropy. Each internal node represents a decision based on specific feature, and each leaf node assigns a predicted class. One of the strengths of decision tree is that they are highly interpretable, making it easier to understand how the model is making predictions. In this final step, we apply the full classification pipeline. The dataset is split into 80% for training and 20% for testing. After making predictions on the test set, we evaluate the model's performance using the F1 score. This metric is especially useful when dealing with imbalanced classes, as it considers both predictions, precision, and recall. A strong F1 score indicates that the model is reliably distinguishing between different diabetes categories. Now, I will walk through how to implement this Cycon machine learning tool for this diabetes classification task. Let's name our project first, and then let's give a brief description of how to implement this task. Then, in the drop-down list, we choose tabular as a data type, since our data is in CSV format. And then let's click Attach File to upload our CSV data. After successfully uploading this data, you can see all of the summaries of this dataset. And if we click this Data tab, it will give more detailed summary of each columns. And then we click the target label to choose our target column, which is the class. And then let's click machine learning algorithm to choose our decision tree classifier. Finally, let's choose F1 score as our evaluation metric, and then we click perform. Now we can see the F1 score is 0.96. It is very close to 1, which means it is very close to the perfect prediction. That means our model was able to very successfully predict the output with our input data. Thanks for watching.